The arrival and the mystery. It all began with a faint flicker, a subtle blip buried deep within streams of astronomical data. At first glance, it was easy to overlook. Just another anomaly among countless observations. But this was different. This presence was cold, silent, and moving at a speed unlike anything we had ever recorded passing through our solar system before. From the remote peaks of Mauna Kea in Hawaii to the clear skies above the South African observatories, telescopes caught the object's approach. Then came the official confirmation from NASA. A new object had been detected, uncharted and unbound by the gravitational rules governing planets, comets, and asteroids we've come to understand. Most chillingly, it was coming from outside our solar system, crossing the boundary into our cosmic neighborhood with a velocity and trajectory that defied prior expectations. Initially, it looked like just another rock, nothing extraordinary. But as hours passed, scientists began to notice subtle irregularities. Its speed was impossibly fast. Its path through space was too perfect, too calculated to be random. Its reflections were unnaturally bright, too intense for an object of its estimated size. When astronomers traced its journey backward, the results chilled them to the core. The object was headed straight toward the very heart of our solar system, the Sun and everything that orbits it. For decades, we've held onto the belief that space is a silent void, cold, empty, indifferent to life and human presence. Yet, here was an object, silently gliding through our cosmic backyard, forcing us to reconsider everything. The James Webb Space Telescope, the most powerful observatory ever constructed, designed to peer billions of light years into the past, was now trained on this visitor. What it began to reveal was something deeply unsettling, something that humanity might not yet be ready to understand. Because as researchers gathered data and debated theories, a new question arose. What if this visitor isn't just passing through? What if it's watching us back? Between June 25 and June 29, the object was first detected by ATLAS, a high-speed sky-scanning system created to catch potentially hazardous asteroids before they reach Earth. But this was no ordinary asteroid. Its velocity surpassed an incredible 152,000 miles per hour. Its orbit did not conform to any known gravitational loops or cometary paths. When astronomers simulated its trajectory backward through time, its origin pointed not to the familiar Oort cloud or the far reaches beyond Neptune, but to interstellar space itself, possibly near the core of our galaxy. This was no leftover fragment from our solar system's formation. This was a wanderer, an ancient traveler that had been journeying silently through the void for tens of thousands of years, unnoticed by human eyes until now. Yet, the mystery extended beyond its origin. Why had it arrived at this moment? Before 2017, we had never witnessed a single interstellar object. Now, we've seen three, each stranger and more inexplicable than the last. Once the initial confirmation came through, scientists worldwide scrambled for time on the James Webb Space Telescope. Webb, built to explore the furthest reaches of the universe, was now tasked with focusing on something far closer and far more unnerving. The object's brightness did not match its size. Its surface reflected light with an intensity that should have meant it was enormous. Yet measurements suggested something far smaller. This disparity implied the surface wasn't behaving like rock or ice. Instead, it was highly reflective, cold and possibly hollow. Harvard astrophysicist Avi Loeb, who famously proposed the possibility that the 2017 object, Oumuamua, might have been artificial, stepped forward again. He urged the scientific community to look for signs of non-gravitational acceleration, subtle deviations in the object's motion that could not be explained by the sun's gravity alone. If such deviations existed, they could imply that the object wasn't just drifting. The implications and the silence. To fully grasp the significance of this discovery, we must look back at the two interstellar objects that preceded it. In 2017, Oumuamua shocked the world with its strange, elongated shape and lack of a cometary tail. It exhibited a mysterious acceleration after passing the Sun, without any visible signs of outgassing or propulsion. Then, in 2019, Borisov appeared, a comet, yes, but faster and more volatile than anything astronomers had seen before. Each of these objects raised more questions than answers, challenging our understanding of celestial mechanics and cosmic phenomena. Now, 3I Atlas combines the baffling brightness of Oumuamua with the velocity and trajectory of Borisov. It neither behaves like a typical rock nor fits neatly into the comet category. Astronomers are now entertaining more radical possibilities. These events may not be random or isolated but part of a larger pattern, a wave or sequence of contact cleverly disguised as cosmic coincidence. For centuries, our skies were empty. Then suddenly, they weren't. And the only variable that changed was humanity itself. As more data streamed in, the James Webb Telescope's infrared instruments revealed an unsettling pattern. The object was accelerating ever so slightly, but not in a way that solar radiation or comet outgassing could explain. There was no comet tail. No particle emissions. Yet the object kept slipping from predicted trajectories with eerie precision. Its thermal signature was stable, not chaotic like natural ice or rock, but patterned and directed, hinting at intentionality. Behind closed doors, scientists whispered what they couldn't say publicly. This wasn't just a passive visitor. We might be under observation ourselves. Detailed spectral analysis shattered expectations. Instead of typical minerals or ice, the surface composition showed advanced carbon structures, materials more often linked to engineered technologies than natural geology. Reflectivity was unusually high, with signs of symmetrical spin, something almost unheard of in random cosmic debris. One side absorbed more heat than the other, possibly indicating purposeful design. Electromagnetic fluctuations hinted at internal complexity, cavities or layered densities far beyond anything expected from a natural object. Suddenly, silence took over. Agencies like NASA, ESA, and ISRO pulled back from public updates. Pages and mission timelines vanished. Requests for raw data were denied or heavily redacted. Researchers were reassigned or removed from teams. What changed? Analysts now believe that something extraordinary had been discovered. Something too profound for public release. Because when a discovery challenges the very frameworks of physics, security, or cultural beliefs, it ceases to be just science. It becomes a matter of control. And in space, control can mean silence as much as signals. As this object glides silently through our solar system, the realization grows. This is no longer merely a data point or curiosity. It is an inflection point. A moment forcing us to reconsider centuries of assumptions about space, solitude, and humanity's place in the universe. If this object is artificial, then it was created by a civilization far older and more advanced than ours, capable of constructing machines that can survive millennia drifting through space, perhaps never needing to communicate verbally because their mere presence is a message. If it's not artificial, then we've discovered a natural phenomenon so rare and advanced it mimics design, perfectly deceiving even the most experienced scientists. Either way, the conclusion is inescapable. Our understanding of the cosmos is incomplete. The James Webb Space Telescope has held up a mirror to our ignorance. We are no longer staring into the void. The void may be staring back, and what it sees may finally be worthy of attention. Among the scientific community, a more disquieting idea spreads, not in papers or public conferences but in hushed conversations and encrypted exchanges. What if this object wasn't found by chance? What if its arrival, the sophistication of our instruments, and the timing of the James Webb observations were all variables in a cosmic experiment? Not just a random artifact passing by, but a probe waiting to be noticed, an invitation from a civilization watching from afar. For billions of years, silence reigned. No signals. No messages. No obvious visitors. Now, as AI advances, quantum physics accelerates, and humanity reaches beyond Mars, something has shifted. This quiet, precise visitor has drawn our greatest telescope away from distant galaxies to our cosmic doorstep. Could this be the moment where we become the data point? Where our science, fears, and silence become part of an observation? Because perhaps the most terrifying part of this discovery isn't what we saw. It's the realization